Okay, good afternoon. I think we'll make a start at this point in time. I think the number of people joining has slowed down a bit, so that's good. Welcome along to today's webcast, Civil3D webcast on corridor volumes and quantity calculations. The plan for today is to go through effectively the pre-existing functions for this. There are no new functions in 2012. So we're going to be looking at the pre-existing way that you would calculate the volumes in a corridor. This is very similar to what I would do in one of my standard training sessions. We may not go for the full hour this week, but I always think that and we always do, so we'll see how we get on. So if there's any of you who have joined in hoping to see something brand new and exciting, my apologies, but feel free to close down the webinar now if you are not terribly interested in seeing the old stuff, and download it from our website later on, and just scroll through quickly what I'm doing for this session and see if there's anything new you can pick up from that. I won't be offended if you choose to do that for the old hands. For those who haven't seen this before though, I would suggest hanging around, because it is a bit of a process, and it is good if you haven't seen it before to be able to see it done before you. So in the background here we have the usual list of suspects who will answer your questions. You've got a question box in your toolbar there. And we've got Jay Joshi and Chris Blair in Auckland, who can look after your needs, and also in Sydney we have Sean Toomey and also our new man, Matthew Ray, our new Civil3D man in Sydney. So welcome to you, Matthew. Alright, well, that's the intro out of the way. I think we should just rip into the demo. So I've got a pre-made drawing here to get us started. Just let your screens catch up for a second there. Now you should all be able to see that. Alright, I've made a corridor. It's got a intersection, it's got a widening in it, and it's also got, if we have a look at the the datum surface, it's got a top and a datum surface made. If we just have a look at the datum surface for a moment in the object viewer, you see that what I've also done is, for a section of this roadway, I have deepened the subassembly that's been applied on there. So I've made my base and sub-base much thicker than everywhere else. So, you know, mimicking a soft area in here, we've had to put in cut down further and put in a great amount of backfill. So we've got a reasonably complicated sort of corridor, sort of mocking up some of the conditions that you're likely to have when you're building your own corridor. So let me have a quick look at that in relation to the ground surface, and then we'll move on. So usually the datum surface and the ground surface is what you're going to be comparing to get your earthworks values, or the cut and fill you need to do before you start filling your pavement materials back on top. So you can see we've got a little bit of fill to be done, and if I turn the surface upside down, we've got quite a bit of cut. Got a fairly steep hill going on here. So that's what the model basically looks like that we're dealing with. Now, in terms of just getting a straight number out of that, the easiest way to do that, and the fastest way, is just to pick a surface, any surface, doesn't matter which one. Up here in the ribbon, oh, by the way, I have started recording this session, so you will be able to download this from the AEC website later on, probably next week, about halfway through next week. Picking a surface, up in the ribbon we have the volumes button here, so I'm going to click on that. In this dialog box that comes up, we click the first icon on the left here, we select a base surface, which is always the ground. The comparison surface is our datum surface for our corridor, and straight away we're getting out, if I scroll to the right a bit, a cut figure, a fill figure, and a net. Now that's over the entire drawing area. So anywhere those two surfaces are over the top of each other, those will show up. You can also put in bulking factors here if you want. Cut of 1.3 and a fill of 0.9. And that all that does is change these cut adjusted and fill adjusted numbers, and you get a different net adjusted from the solid measure value, which is here. Alright, so that's the real fast way to get a number out over the entire site. It's as accurate as the triangulation of your two surfaces is. Okay. However, people in relation to corridors usually want to be able to duplicate the old-fashioned method of doing the manual calculation for end area method along the corridor, chainage by chainage. So in order to do that, there are some tools up in the ribbon here. They're under the Analyze tab in the ribbon here. So you go to the Analyze tab, and there's two parts to it. The first one is Compute Materials. The second one is Volume Report. Now before you can get this to work, or the Compute Materials to work, you need to have made some sample lines along your corridor. Now these will be different from the sample lines that you use for making cross sections, in that you want to have them a lot more closely together, so that where you get a change in the corridor, like such as in here, in its width, you can get slices much closer together, and so the calculation is going to be much more accurate. So the easiest way of doing that, if we go back to the Home tab in the ribbon, we'll generate some sample lines here. Sample lines at the Home tab of the ribbon. It says pick on an alignment, so I'll pick my centerline alignment to the road, and we'll give it a name, parent name of the alignment. Then I like to call mine volumes. So it's got the name of the alignment, then volumes, if I can spell it correctly. Get the O and the L around the right way. Alright. So that I can tell this sample line group as distinct from the sample line group I made to generate my cross sections. So this is my sample line group called the name of the alignment, which I think is utility 2, and then the word volumes. Can leave the styles as they are using the ANZ template. And then down the bottom here we choose what things do we want to be able to sample using these sample lines. So I've got the EG surface, which is good. We've got the corridor shapes, or the corridor itself. We've got the top surface and the datum surface if we want to use either of those. So we go with all of that. And we go OK. On the toolbar that then comes up, the easiest way for volumes, I find, is from the drop down here on the right, choose Make Sample Lines from Corridor Stations. So everywhere you've got transverse blue lines on your corridor, it's going to make a sample line. And for me, 15 meters out either side will be fine, so I'm just going to go OK here. And there we go. Escape to finish the command, and that's all the sample lines set up for my volume calculations, for my end area method. So it's going to take a slice through the corridor at each one of those yellow lines. Now, what we're that being done, we can then switch back to our Analyze tab, and we can start this calculation. The first one I'm going to do is just compare, well, the earthworks calculation, if you like, compare two surfaces together. So let's go and do that first. By the way, just before I go and do that, if you ever need to turn off these sample lines, or you don't want to see them in your drawing, often you don't once you've done this calculation, just turn them off by layer is the easiest way to get rid of those. See sample lines, I think, is the layer. Alright, so we go to the Compute Materials button now up in the Analyze tab of the ribbon. This is the first one you do, and it basically says what things do you want to compare together when you do this volume report. So what are the things you want to have out in this volume report? The second option here is just to print the volume report once you've done that. So we'll go Compute Materials first. says which alignment and which sample line group, so that's fine. We go OK. And we get into this dialog box. Now there's a whole bunch of different quantity takeoff criteria you can choose from. Each is just a style. The ones you use most are the earthworks and the paving materials. All these other ones work in a similar fashion, they're just got more options you can set. Let's go and have a look at the earthworks one, which simply compares two surfaces together, in this case the EG surface and a datum surface. So let's click on A and Z surface, and you can see here in the listing down the bottom here, it has two surfaces it's going to compare together, but it's going to give you a report that is generated station by station along the corridor, like an end area method. In fact, what it's not exactly, well, if you want to use an end area method, you can choose average end area method from here, or prismoidal, which is a slightly more accurate version of the average end area method. However, they have also put in, I think it was 2011 this came in, the composite volume possibility is there when you're just comparing surfaces. So that actually does an isopack calculation from chainage to chainage. So we might as well leave it, that's actually going to be more accurate, so we might as well leave it at that for the moment for the surfaces. And we'll make our, set our surfaces, which is by clicking on where it says click here. So the ground surface is EG, and the datum surface is the corridor datum. And we go OK. And it goes away and thinks about it for a moment. Now what is important to consider here is when it's doing this, this calculation for comparing two surfaces together, it only compares those two surfaces underneath the sample lines that you've drawn, so that where those two surfaces exist outside of the edge of the sample lines, for instance, out in this area here, it's not going to give you the area in that, or the volume in that area there. And similarly for the rest of the site as well. It's only where those two surfaces exist underneath those sample lines. So if your sample lines are only, say, 2 meters wide and don't extend to the end of your corridor, you're going to be missing some of the, to the edge of the corridor, you're going to be missing some of the volume. So make sure that your sample lines go to the past either side of the edge of the road, as I have here. Alright, so once we've done that compute materials, what I usually do is go and click on it again. I'll show you why when it comes up. Go OK to that alignment and that sample line group. And the reason is I like to check, or want to check, the cut and fill factors, or the bulking factors that are in here. And I usually set them to 1 because I'm working in solid measure. Most of us work in solid measure. Although you can put those in there if you want to. Now, I'm not sure why the first time you see this list that you don't see those by default. It's a bit annoying to me, but just make sure you click on the compute materials the second time and check your cut and fill factors are as they want. Or you can go into the style for that particular criteria and set those cut and fill factors to 1 if that's what you use all the time. That's all I'm going to do in there. Go OK. Alright, that being generated, we can go and hit the volume report button here. So we've done the compute materials, and the volume report simply takes that material that we've specified and makes a report out of it. So let's click on volume report. That's the alignment, that's the sample line group. That's the material list we just made. Actually, I should have renamed that to earthworks. We'll do that when we go back through. It's good to keep that a bit more identifiable. But the one thing we do need to select and make sure it matches is the style sheet. So we're doing a comparison between two surfaces, or an earthworks comparison. So we have to set an earthworks style sheet. So I click on this button here. And there's one here called Earthwork XSL. There are some ANZ ones, but don't use that for the moment. It would appear that in the implementation of the country kit, something is not right there when it's been written to the disk that you would have got for Civil3D 2012 and 2011. I think it was the same. So you just use the Autodesk ones here that first come up. So we're using an Earthworks style sheet. So we go open and OK. And once it does that, we can go and see our volume report comes up. I'll just let your screens catch up for a second there. You should be getting in a second. There you go. You should have it now. Okay, so this makes an HTML document. The figures here, you've got the area of cut, area of fill, volumes of each, and the cumulative figures at the end here. I can scroll down to the bottom of the list in just a moment and get the cumulative cut and fill over that area down here. So that's the 1,304 cubic meters of cut is the total there. Now I think if you recall, or if you look very carefully when you compare the surfaces together, we had a little bit less cut than that, I think, and the reason for that is that we're not capturing this little area in here, which has some fill in that part of the corridor. So that's the little difference there and the thing to be aware of. You can keep this as an HTML if you want to, but most people want to have it out in some other form that they can keep a hard copy, such as Excel, which is or Word. So you can just cut and paste straight into those. So if I go Control A to select all, actually we need to bring up my Excel here. Right, Control A and then Control C to copy it, and we can go back into Excel. Control V to paste it, and then we can stretch out all the oops, stretch out. There we go. All the columns as we need to, and you can put your own headings and things in here, and you know, eliminate any of these columns you don't want, etc., etc. Alright, that's the easy way to keep a hard copy, and then you can go take it away and play with it, and add other components to it as well, other volume calculations you've done for other alignments in the drawing. Alright, so that's just an exact copy. It'll also paste into Word as well. It just comes in as a table in Word. Okay, so that's the first one. The second, just the screens catch up there, they're just doing a slow thing. There we go. Okay, the second thing we might want to do is if we have a look at our corridor components, or our corridor assembly, is to be able to get the volumes of all the different components in here. So we've got the base material, the sub-base, Pave 1 and Pave 2, which are our paving layers if you've got two of them, curbing, concrete, etc. So we can do that using a slightly different version of what we've just done. So we can keep the same sample lines and just run another volume report. So let me go back to the Compute Materials button here in the ribbon. So we've got utility 2, yep, and the right sample group, so it's the same as what we had before. And here is the Earthworks material list that we did before. So what I'm just going to do, yeah, material list. So I'm just going to rename that Earthworks, so we can keep it distinct from what we're about to do, which is import another criteria here with the button down on the bottom right. And we're going to grab the one called ANZ Paving Materials. Go OK. Now, as soon as you go to this, it doesn't have any surfaces to work with, so we can't use the composite volume method, which we use to compare two surfaces together on isopack technique. So we've got to either choose average end area method or the prismoidal method. I'm going to choose prismoidal, being slightly more accurate. So what we've got here is a whole bunch of corridor shapes we can specify. Now I'm going to well, the way it works, I'll show you how it works. I can set pave 1 out of the corridor to match the pave 1 for this particular volume report. I can go through and do the rest of those, or I can just hit the map objects with the same name button up here and it'll go work out pave 2 base and sub bases in there. Concrete, I might want to have the curb concrete come out in there. So that being done, we've set all the ones we want in here. This is just a style, by the way, the ANZ paving materials, so you can go into that style and add some more shapes if you want additional shapes in the report. We go OK. It tells us not all of them have been mapped. For instance, the gravel here. That one, well, the gravel component is when you've got a shoulder sub-assembly in your corridor. There's a component called gravel. We don't have that, but we can just go OK and it will get left out. In fact, we may not even have a pave 2 in many circumstances, in which case we would just leave that blank, and that wouldn't come through the report. You'll see when the report comes out there'll be no gravel because we haven't set anything. We go OK and OK. And I'm going to change the prismoidal method, which is down here. So here's our material list 2, and I'm going to remember to rename this time and call it corridor shapes. Good grief, what's happening to my keyboard? I don't think it's my keyboard, I think it's my typing. Okay, so we've got another material list called corridor shapes, and you can see these are what we've set in that last dialog box. And it's got a just using no bulking factors, which is good. If we don't like, you can see the one we've got here for the curb shape. The name of it's concrete. If we don't want concrete coming out in the report, we can write curb here instead, and we'll get that word coming out in the report instead. The base and sub-base, if we're in New Zealand, the sub-base would be AP65, would be gravel of whatever type in Australia, of the grade that you specify. AP40 for the base. And we go OK. So we can rename those as you want. That's how it's going to come out in the report. Go OK. And it goes away and thinks about it again. There we go. And we should be ready to go and make our volume report from that. So some of your screens catch up. Okay, I think we should be there. Alright, so we can generate a volume report for that now, for the corridor shapes. So again, that's our alignment. That's our sample line group, our volumes one. The material list we want to use is now the corridor shapes one we've just made. And again, you need a style sheet that matches corridor shapes. So we go into the style sheets, and we don't want the earthwork one this time, we want the select materials.xsl. Select materials does the corridor shapes. So we open that one and go OK. That being done, you can see the style sheet sets up a different style to the table. Effectively, that's what it does. It tells it how to set up the table, set out the table. So you can see station by station, it's giving me my AP40, AP65, my curb concrete. These are the ones I renamed. The ones I didn't rename stay as they are. And there is no gravel in here because we left it blank. So that's what we were talking about. Now if I scroll down through the list here, just to prove that it is actually working, to about chainage 135, somewhere around here. Okay, let's have a look at a 2 meter section of the corridor between chainage 24 and 26. Let's look at the AP65 figure. We've got 2.3 square meters and 4.3 cubic meters volume of AP65. So if we go somewhere to in the middle of our widening of the road that we did, and it also has the sub-base deepening at that point. So if we go past about chainage 165, somewhere in here, I'm trying to find a 2 meter section, here we go. So you can see the AP65 figure's gone up in terms of its area and its volume, so that's what you'd expect. This has got to be a lot easier than calculating it by hand too. I know a number of you are still doing that. Yeah, this should make your life a lot easier. So we scroll down to the bottom and here's our total figures for the cross-sectional shapes along that alignment. And now this is a little thing you need to be aware of. It's along that alignment, so it's the parts of the corridor that are attached to that alignment. Parts of the corridor on other alignments are not included in these figures. So let's go and have a look at what I mean there. Let me zoom in here. That's okay if you don't have an intersection, it'll just do the entire length. If you do have an intersection, there's a slight complicating factor. So let me just get your screens to catch up there. Okay, I think you can see this now. I'm just going to outline an area here. So this is the edge of my corridor running up here. When it gets to the curb returns, it will do an area like that. So I think you can see that green area that is currently highlighted, hopefully, on your machines. That is the area that's going to be included in the calculation of, or the volume calculations for the cross-sectional shapes or the paving materials that we've just done along this alignment, because that's the shape of the sub-assemblies that are hanging off this alignment. The other parts of the curb returns, which are, I'll just run that command again, from here to there, to there, out to the edge of the curb return there, and around this daylight line. That area in there, shown in green, is hanging off this alignment here, which is our curb return alignment. So you'd need to do another series of sample lines and another volume report along that curb return, one on the opposite curb return as well, and then you'd need to look at the other road coming in the other way and do another volume report along there in order to get all of the volumes of the entire model in there. So that's something to be aware of. It's the way it's always worked. But it's something that's pretty easy to let slip by if you're not aware of that. So just make sure you're aware of that, and then you can copy and paste them all into Excel together and get a grand total. Okay. So that's the basic, or the standard, if you like, compute material and volume report options. There is, however, one more thing that's come in with the QTO Manager, Quantity Takeoff Manager. Now, it doesn't do a huge amount for us, but does do a little bit for us. So I'll show you that and how that works as we have time today. So let's go and have a look at that. So for those who haven't seen the Quantity Takeoff Manager, I don't know many people that are using it a great deal. It's mostly been designed for AutoCAD objects, but it will work with some Civil3D objects, and the corridor is one of those. So if I click on QTO Manager here, I don't know if any of you people have had a look at this, or some may have, some may not have. But if we go and just have a look at some of these things, basically it's got a number or a code that applies to each of these, and then you have a number of different costs, or, well, no, they're not really costs. If you put in a formula here, it'll be a cost. It can be calculated as a cost, but it's a quantity measure, if you like, either in meters, cubic meters, or sometimes square meters, or each. And this is a file that's kept in the background. Now, I've made some of my own down here, just two that I'm going to show you how to use for a corridor, which is an area one. I've called it pave one area, and put it as a square meter value, and a curb length value, and given it a meter or linear length measure. Now, how to put those things in? If you come up here to the top left, there is a drop down there, and you can go Open Pay Item File. Click on that. It shows you the pay item file, and it's currently using to get all this information. And it's this one here, Sample ANZ CSV by default when you're running the ANZ Country Kit. I'm going to select this line here, and get to the beginning of the line would be good. Sometimes hard to get to there. Do it. Double click, right? No, it's not going to do it. Let's try again. Now let's actually do it from here. There we go. This is, believe it or not, the easiest way to get to it. I just need to get it to work. Come on. Almost. Come on. We'll try that, see if it's got the whole thing. Control copy, bring up Windows Explorer. Paste it into there, Control V, no it hasn't. Just got to get the right address for this thing. Autodesk. Okay, let's try it. Oops. Right, there. Shift to there. Copy that. Control V, so application data. Space data. The application space data. Okay, that should get us to the right folder. Just a funny selection thing going on there. Yep, this is the right one. Now in there that's the sample ANZ CSV that it's accessing to get all this information. So if we just open that with, well, you can do it in Excel if you want, but Notepad's happy with it too. And here's all the list of those volume types or measure types. Just down the bottom, I put in Z1 and Z2, just so it ends up at the bottom of the list. You've got pave one area in square meters, or we called it pave one area, and called this one curb length in meters. That's all we've done. Just added that to the bottom of the list. In that file, and it comes through as Z1 and Z2 on the bottom of this list. So we can call those what we want in that CSV file. So that being done, we can go and apply those to a part of the corridor. So let me close that panorama window. Select my corridor here and go into the corridor properties. And in the corridor properties, there's a tab called Codes for the code set that the corridor is currently using. You should see that on screen now. I'm going to go and edit the code set style for that particular, or the one that I'm currently using for that corridor. So I click the Edit button right here. And in here you can see it's got a last column on the right here called Pay Items. Now pay items, unfortunately, cannot be assigned to shapes. They never have. Don't know why, but they've just never done it. I asked them why, but never got a response back, and they haven't built it in either. But what we can do is apply the linear ones to the point. So it's listing of points here. The point called top of curb. I want a linear figure out for all of the top of the curb in that corridor. So I click on the little truck on the right here. Scroll through all my pay items and can assign that as the curb length one I've created in linear meters. So go OK. So it's Z2. And if we scroll up to the top, all of the parts of my corridor called pave or pave 1, set it onto the pave, will have the pay item, my square meter figure, which is the pave 1 area, or the pave area. Okay, so that's all you need to do for those. So I've got a linear top of curb, and you can apply that to any other ones you want to. Just give them a different material list item, and they'll come out in a little report at the end. So had that haven't been assigned to the corridor, we go OK in the code set and OK. And once that's been done, to get it to actually apply it to the corridor, all we have to do, finish just thinking about that, so still thinking about that, machine's just catching up here, just give it a second. There she goes. Okay, did come back to me. I'm still running my 32-bit machine here at the moment. I do have a new one, but I'm still getting it built and complete. But here we go. We're back, and from that point, just rebuild your corridor, and then we can get our quantity takeoff report. Still rebuilding my intersection, and we're just about done. And come on, baby. We're back, almost. This machine seems to be having a go slow this afternoon. Maybe it's because I've got the webinar thing running again. It might be doing it. It is rebuilding it because I can see things happening on my screen. Come on, buddy. Yep, it's definitely the webinar thing slowing me down because it never took that long before. Yeah, and an autosave. Brilliant. Okay, once that's done, and everything catches up, you can then use this Takeoff button up here in the ribbon. So click on the quantity takeoff to make the little takeoff report. It's not huge, but it gives you the answers straight away. So this report type is just a summary report. Go over the entire drawing extents, or you can limit extents to a particular alignment, station range, etc. I'll just do it for the whole thing. Go compute. And when it first comes up, you'll see it won't look particularly appealing because it first comes up as an XML report. I've never found anything that actually uses those XML reports, but we can change that in just a second. There we go. Here's your XML report. What it looks like, not particularly appealing. So we can, from the drop down at the bottom here, change it to a summary, an HTML summary or a text, whatever we like. And simply all it does is tally up for the entire corridor all of the curb length, or the Z2 figure, and that's the entire length of all the curb on both sides of the road and around the curb returns. And Z1 is the entire paved area, and you could do the same thing for another one for footpath area, another one for daylight area, for instance, another one for berm area, and you get a full report for the entire corridor if you wanted to. It doesn't do it station by station, it's just a figure for the entire corridor, but if you want to use that, that's how it works. To be honest, I haven't used that particularly much at all. I find it's almost just as fast to, and just about as accurate, to use the measure geom tools like the lineal distance or the area such as we had before, and just clip your way around the corridor over the areas that you want, and you get more control over the bits that the areas that you get out that way. If you're wanting an area, obviously it would be nice if you're able to use that tool for the volumes of the corridor, but it never has done that. So there's the area of that is 104.98 square meters, or very close to it. All right, well essentially that's about what I wanted to cover for this session. So we're finishing a little bit early. You can go and have a cup of tea if it's that time of the day in your part of the world. So thank you for tuning in this afternoon. Let me just go back to my PowerPoint here. The demo is finished, so thank you very much. Have a nice afternoon and even better weekend, and we'll see you back on the next webinar.